Alright, we're going to take a look at section 9.2, the hyperbola. And a hyperbola is the set of points in a plane with the difference of distances between the foci constant. Now remember, in ellipse we had two foci, but in an ellipse it was the sum of those distances that was constant. Now it's the difference. So if we take a look, come down here to the picture of the hyperbola down here, and I've drawn a hyperbola, and this is what we get when we have a hyperbola. We get these two parabolas either opening left and right, and these are symmetric, so opening left and right, or up and down. And just like in an ellipse, we start with foci, and here is one of my foci, and here is the other one of my foci. Now in an ellipse, it was the sum of these two distances, d1 and d2, that were constant. In a parabola, it's the difference. So here we're looking at the difference in the distance. So here, if I was looking at the difference, I would be taking a look at d1 minus d2, and that is always a constant value. And so where these differences are the same, what it gives us is all of these points then, all of these points on this parabola have a difference in these distances that is constant, and the same on this side. And so similar to an ellipse, only difference is here we're taking the difference instead of the sum, and when we take the difference as opposed to the sum, we get now shapes for a hyperbola. Okay, so we have two forms, kind of the standard forms of a hyperbola. And the difference is just the order in our variables. Notice if my x variable comes first, so I have x squared over a squared, similar to an ellipse, and then y squared over b squared. Notice now, here we have a subtraction, so that is different. In an ellipse we had an addition sign here, and since we're looking at a difference here, this is a subtraction sign. So if our x term comes first, then we are going to be crossing or traversing some sort of horizontal line here. And you can see in this case, this one is just going to go across the x-axis here. So when we say this crosses the x-axis, we would say it's traversing the x-axis. When it traverses the x-axis, our hyperbolas are going to open left and right, and you'll notice here I've labeled this as the traverse axis, the x-axis. So that happens when x is listed first and y second. If we come over to our next equation here, where y is listed first and x is second, now we're going to traverse the y-axis. Since y is coming first, now our traverse axis is the y-axis, and here are the vertices of my hyperbola traversing the y-axis. Here's our focus, and our focus always sits just a little bit above and a little bit below the vertex, and same over here if we're traversing the x-axis, a little bit to the right and a little bit to the left for the foci. Okay, so just a couple things to note between the difference between this and the hyperbola, the ellipse is subtraction sign here. If this was an addition sign, we'd be graphing an ellipse. And the difference in the distances now, the difference of the distances as opposed to the sum of the distances. Okay, so now let's take a look at a couple other details. Let's start first with finding the focus, or the foci in this case. Now, to find the foci, we're going to use the equation c squared equals a squared plus b squared. This is a little different than the ellipse. In the ellipse, we had a subtraction sign here. In the hyperbola, we have an addition sign here, so that's something to make note of when you're finding the foci. Translation of a hyperbola looks very similar to translation of an ellipse. So we still have a minus sign in here, which is given us in a hyperbola, and then x minus h, y minus k. The origin or center of our hyperbola then is going to be at hk, and notice again the signs are opposite. If it's minus h up here, it's a shift of a positive h down here, minus k, shift of a positive k. Alright, in a hyperbola we also have asymptotes, and if we take a look at both of these graph dotted lines down here, as usual, are indicating our asymptotes. So our graph here, our parabola is going to approach these asymptote lines but never cross. Approach but never cross. And so the same thing here, if it's traversing our y-axis, we still have our same asymptotes. It's going to traverse and never cross. We're also going to have to find the equation of these lines, but that's really simple. You already know how to find an equation of a line. So to find the equation of the line, all we have to use is slope-intercept form, where we find the slope of these lines, which will be pretty easy to do because we can have the coordinates of the center here and also the coordinates of these corners. So we've got 2 points there. We can find the slope between those. We can also usually find the y-intercept here, where it's crossing the y-axis. That would be my b. So all I have to do is plug that information in to write the equation of these lines. So when we're graphing hyperbolas, we're not only going to graph the actual hyperbola, we're also going to create these asymptotic lines, which is really pretty easy. Notice all we do is we make a rectangle. We go from the center, and we're going to go out a distance of a and b to find the dimensions of my rectangle. So notice, just like in an ellipse, the denominator here is a squared and b squared. We're going to start at our center, travel out a in both directions, travel out b in both directions. Then that allows us to draw our rectangle around here. Once we have our rectangle, our asymptotes travel through diagonally through the corners of the rectangle. Draw the asymptotes in, and then the vertex will be on the transverse line. Draw the vertex, and then go ahead now and draw your hyperbola. It's traveling out here, approaching these asymptotes. If we are not at the center, or if we cannot easily identify our y-intercept, then we're going to use point slope form. Slope will be really easy to find because, again, we'll just be finding the slope as always. And then instead of using the y-intercept, all we have to do is find one place where this graph crosses a nice clean point, and then we just plug the coordinates of the point in there, and then we can get the equation for our asymptote that way. Alright, let's take a look at graphing a hyperbola here. So in the equation here, we're asked to graph this hyperbola, x squared over 36, y minus y squared over 9 equals 1. Because we have a subtraction sign here, we know this is going to be a hyperbola. Addition sign, that would have been an ellipse. Identify the locations of the foci and the equations of the asymptote. Alright, well, let's first start by graphing it. So we want to consider first whether there are any shifts in our graph. And if we look up top here, we don't have x plus anything or x minus anything, y plus or y minus, so we know this thing is not shifted. So we know our center is right at the origin. And now we want to travel out in both directions. And notice the travel in the x direction would be the square root of this, since this is a squared. Then the travel in the x direction in both directions would be a. So a here is going to be 36. Sorry, a here is going to be 6. And if we look at b here for the shifts in my y, they are not shifts in y, but how far we're going to travel in the y, that's going to be 3. So all I do is I come to my center, and I travel 6 units each way on my horizontal. So let's see, 6 units each way. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Okay, 3 in my B. 1, 2, 3. 1, 2, 3. Okay, and then we're going to draw in the corners of this and draw this in dotted. We do need to draw this rectangle. It's going to make it really easy to make our graph, but it's not part of our graph. So we draw this in dotted. Alright, now what we want to do is once we get our rectangle done, now we can draw our asymptotes in here. So our asymptotes are going to travel diagonally through the corners of my rectangle. So let's see. Okay, once I've got this done, I'm ready to graph. I just got to figure out was this going to be it's going to traverse a horizontal line or a vertical line. So we go back to our graph. Whichever comes first is what we're going to be traversing. So since x comes first, that's the axis we're going to be traversing. So we would come over here now. These then would be the vertices of my graph, since we're traversing or crossing this x-axis now. And I'm going to draw my hyperbolas coming out this way. Okay, so had y come first, I would have used these as my vertices, and I would have been graphing my hyperbola going that direction. But x is first, so that's the transverse axis. All right, now I need to identify the locations of the foci. So remember, in a foci, it's c squared equals a squared plus b squared. So all I need to do, well, obviously this is a squared and that's b squared, so it's going to be c squared is equal to 36 plus 9. C squared is equal to 45. Okay, so c is equal to the square root of 45. We get an approximation for that, approximately 6.7. So I'm going to come now on my transverse axis and come out 6.7. Well, we already knew this was 6, so it's really just coming out that 0.7. So looks like my foci are going to be right about there, both of those directions. Now I want to find the equation of, all right, now I want to find the equations of my asymptote. So I think here we've got a real nice, easy to find y-intercept, which is 0. So I know this in my slope-intercept form. I know that my y-intercept is 0, so that's pretty easy to find. So now all I need to do is just really identify the slope, and I've got the equation for these two asymptotes. So if we take and travel from our point 0, 0, that's one of our points, 0, 0, and our next point, if we come out to the corner of this rectangle, we know it crosses right there, and that was over 6 up 3, so over 6 up 3. So all I need to do now is find the slope of that. Remember, slope is change in y over change in x. So my change in y, I'm starting at 0 and moving to 3, so that's a change of 3. My change in x, I'm starting at 0 and going to 6, so a change of 6. So it looks like my slope is just going to be 1/2. So the equation of this line now, y-intercept of 0, a slope of 1/2, is just going to be this, y equals 1/2 x. Now, the next asymptote is going to be easy to find because really it's the same thing. Still centered at 0, 0, so my y-intercept is going to be 0, except instead of traveling up 1 over 2, this thing is traveling down 1 over 2, or just the negative of that slope. So it's just going to be y equals negative 1/2 x. And so there are the equations of my asymptotes, and I've answered all the questions they wanted for me. Okay, question 2, I'm going to have you guys try to work through question 2 because we're going to kind of put everything all together. So very similar to what we did in an ellipse here. I've given you an equation and I've asked you to graph. At this point in the problem, we don't know whether we're going to get an ellipse here or whether we're going to get a hyperbola here. Since we're studying hyperbolas, we're probably going to end up with a hyperbola. But we don't know that yet, and we will have questions where you're just given something like this and you're just asked to graph it, and we don't know whether it's an ellipse or hyperbola. But what we're going to do is the same thing we did with an ellipse. We got to get this guy organized so it's in the standard form. And luckily, both the ellipse and the hyperbola have a very similar standard form. So if we scroll back up here, we want this to get organized like that. You know, either x squared over some number. It could be y squared first as well. Over some number, and then again equal to 1 over here. So what we're going to have to do in this problem is we are going to have to organize this. Looks like I've already kind of started it here for you. We've got our x's together and we've got our y's together. But we also want to complete the square here. Once we complete the square, we're going to want to, first we're going to want to get it organized, factor something out if we can, and I think here it looks like we'll be able to factor a 4 out. Looks like in my y's, I'll be able to factor a 25 out. Once we get that factored out, then we can complete the square and get this thing organized in the standard form. Once we get it organized in standard form, then we'll go ahead and try to graph it. So go ahead and pause your video player now and go ahead and try to work this problem. Kind of put all this stuff together. If you can get it, that's great. If you miss a couple things, that's okay. Go ahead and give it a shot, and when you get done, hit play and see how you did. Alright, so we're starting. We've got it organized. My x's together, my y's together. I'm going to factor out, looks like here a 4. So that would look like this. 4 times x squared minus 6x. And then I'm going to put on here plus some mystery box. That's me working to complete the square. Here I'm going to factor out a negative 25. So I'm factoring out a negative 25 first. So it would be y squared plus, oh, sorry, right there, I made a mistake already. If I'm factoring out a negative 25, that's going to be a negative 10y plus some mystery. I'm going to take this 489 and move it over to the other side, so I'd add 489 to both sides. Alright, let's take a look. So here, the reason I factor this out is because, again, once we have a leading coefficient of 1, c, my term c, is just going to be 1/2 of b squared. So 1/2 of 6 is 3. If I square it, that'll be 9. Here, 1/2 of negative 10 is negative 5, and if I square negative 5, it'll become positive 25. These are always going to end up being positive in perfect squares. Alright, so now I've just added some value to the left side. I got to make sure I add that same value to the right side. So let's see here, when I put that 9 in, I actually put in 4 times 9, or 36. So I added 36 there. And here, when I put the 25 in, notice 25 is getting multiplied by negative 25. So I'm actually decreasing the left side by 625 there, I believe. 25 times 25. Yep, 625. So decreasing the left side by 625, I need to decrease the left side by 625 as well. So let's see what we have. So this is a perfect square, x minus 3 squared. So this will be 4 times x minus 3 squared minus 25 times y minus 5 squared. And we have to combine all of these together. When we combine all of those together, we are going to get negative 100 on that side. Now remember, in a hyperbola or an ellipse, I want to have positive 1 over here. So what I'm going to do is divide by negative 100 all my terms. Okay, and so over here, like I was shooting for, a positive 1. Now let's go ahead and simplify these guys. Looks like this first one has a common factor of 4. So I'll divide a common factor of 4 out of the top and the bottom. And so it would be x minus 3 squared. When I divide the 4 out of the bottom, I would get negative 25. Here, notice this is going to end up being a positive value since I've got a negative divided by a negative. So this is going to be a plus sign on there. And it looks like my common factor here to factor out is 25. So I'll factor a 25 out of each of those, and that would leave a 4 in the denominator. Y minus 5 squared. I'm close now. Notice, though, I just need to switch this order, because usually the typical order of a hyperbola is my positive term first minus the next term. So I want to switch these two guys around so it looks like this. Y minus 5 over 4 quantity squared minus then x minus 3 squared over 25 now is equal to positive 1. Now that I'm here, I've got this thing all organized in standard form, and we can tell that it's a hyperbola. Got a positive, then minus the next term. I think we're ready now to go ahead and graph this guy. So we do have some shifts here. So let's take a look. First thing we want to do is find the center. And the center is going to be at x coordinate of positive 3, a y coordinate of positive 5. So I'll come over here and 1, 2, 3, 1, 2, 3, 4, 5. So there's my center. Once I get my center now, I want to draw my rectangle around that. So we can see that for y, that's going to be up and down 2 units. Since this is a 4, the square root of that will be 2. So we're going to travel up 2 and down 2. So 1, 2 up and 1, 2 down. X, the square root of 25 is 5, so that's going to be a travel of 5 in each direction. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, got my rectangle there, so now I'm going to go ahead, draw that in with dotted lines. Okay, once I've got that, I'm ready to draw my asymptotes. So I'm just going through the diagonals here. Okay. Once I've got my rectangle drawn around the center, then I want to figure out which is going to be my transverse axis. Notice y is my first term here, so we are going to be crossing here on some x equals line, but we're going to be going up and down. So this is going to be my vertex, this will be my other vertex, and I'm ready to graph the actual graph of my hyperbola. Alright, now I've got my hyperbola graphed. I'm also asked to find the equations for these asymptotes. So in order to find the equation, I'm either going to need to have a y-intercept, and if I look at my lines here, it's possible but not probable that I'm going to get a nice y-intercept here. So I don't think I'm going to be able to use slope-intercept form to do this. What I will use is point-slope. And so remember, point-slope looks like this, where this is my slope, and these are the coordinates of some easily identifiable point. Well, an easily identifiable point is this center. And if we use that center point, it actually is nice because that center point works for the line with a positive slope, and it also works for this line with a negative slope. So picking the center as my point when we have to use point slope is the best choice. So let's take a look at the slope first. So what we need to do is let's travel from here to here, because those are nice clean points to get. So this corner up there. So it looks like I'm traveling up 1, 2, over 1, 2, 3, 4, 5. So my slope there is going to be 2/5. The coordinates of this center point we already decided was 3, 5. So I'm ready to write the equation for my first line, which is this. Y minus 5, the y coordinate of my center point, is 2/5 times x minus the coordinates of my x coordinate from my center point, minus 3. Now, this line has this positive slope of 2/5, so up 2 over 5. This line has the exact opposite, the negative slope of that, down 2 over 5. So a lot of symmetry, or maybe not symmetry, well actually yeah, symmetry here between these two lines. So down 2 over 5. So really the equation for my next line is going to be almost identical. It's going to be y minus 5 equals, now instead of a positive slope, negative 2/5 x minus 3, because I've chosen the same location for the location of that point. So here are the equations for my two asymptotes. In my math lab, they might want us to write this in slope-intercept form, which would be easy to do. For me, and when we're taking a test on this and things like that, this would be fine. And in fact, a lot of times, to be really efficient when we're writing these lines, a lot of times students will just do this. Y minus 5 equals plus or minus 2/5 times x minus 3, and you get both of those equations for the asymptotes kind of in one shot there. Alright, I think you've got enough information now. You're ready to go out and tackle those problems in my math lab. Have a great day.